Hello everyone, welcome to the video lecture on 5B. So 5B is going to consist of the last 5 sections that we're going to talk about in this class, and that's 5.5, 5.6, and 5.7. Okay, so 5.6. 5.5 first. Last time we talked about adding and subtracting polynomials, or we gave basic definitions of what a polynomial is. So 5.5 is going to start with talking about how to multiply polynomials together. So 5.5 is a multiplication of polynomials. Okay, so to keep things simple, we're going to start with just monomials. Remember, a monomial is like a one-term polynomial. So we'll start with that and we'll kind of build up from there. So to multiply monomials together, let me give you those rules. What you want to do first is just multiply the coefficients, right? So the numbers together. So multiply the coefficients. Then multiply the variables using the product rule of exponents to simplify it, right? So multiply the variables using, and you're going to have to use the product rule of exponents. Okay, so let's do some examples. So here's what I mean by multiplying a monomial times a monomial. So let's say I have a monomial negative 6y squared, and I want to multiply that by 7y to the 5th. Okay, so first thing, multiply the coefficients together. So we do that first, right? So coefficients, right? Negative 6 times 7. What is that? Well, that's going to be negative 42. Then I multiply the variables together, right? The powers, y squared times y to the 5th. And I use the product rule. Remember what that says? If you multiply 2 powers and they have the same base, you keep the base and you would add the exponent. So 2 plus 5 would be 7. So that would be the answer, negative 42y to the 7th. Let's say I have 8s t squared, and I want to multiply that by 6s to the 4th t to the 7th. Okay, so I multiply the coefficients first. So what's 8 times 6? That's 48. Then I look at the variable s, right? So the powers that involve s. So I have s, remember s by itself means s to the 1 times s to the 4. So I would add exponents. Well, what's 1 plus 4? That's 5, right? And then t squared times t to the 7th is going to be t, keep the base, and I add the exponents. 2 plus 7 is 9. So 48, s to the 5th, t to the 9th would be my answer. And of course, you could have more than 2 monomials, right? I could multiply, say, 3 monomials together. Let's say I have 8n cubed times 2n cubed times negative n. So multiply the coefficients first. So I have negative 8 times 2, right? That's a negative 16. And then negative n, remember that coefficient is really, there's really a 1 there. There's an implied 1 there. So negative 8 times positive 2 times negative 1 is going to be a positive 16. And then what's n cubed times n cubed times n? Well, I keep the n, and I just add all the exponents. So 3 plus 3 plus 1 would be 7. Okay, what if I want to multiply a monomial, right, so a single term, by a polynomial, which can contain in general more than one term? So basically what you do is you just distribute in that monomial. So I'll say use the distributive property to multiply a monomial by a polynomial. So for example, let's say I have 2y times 8y minus y cubed. Okay, so I want to distribute in, I want to multiply in that 2y. So I need to first do 2y times 8y. Well, that's just a matter of multiplying two monomials together, right? So, and we just learned how to do that. I multiply the coefficients first, so 2 times 8 is 16. And then y times y is, I have to add the exponent, so 1 times 1 is 2, right? So y times y is just y squared. And then I multiply 2y times negative y cubed. Well, 2 times negative 1 is a negative 2. And then y times y cubed is y to the 4th, right? 1 plus 3 is 4. So that would be my answer. So all you do is you distribute in that 2y in this case. What if we had, go up to a new page here. What about this? X cubed plus 6x squared minus 9x plus 10, and I want to multiply that by negative 3x to the 4th. So same thing, right? I just distribute in negative 3x to the 4th. And it doesn't matter whether I distribute it in from the front or from the back, right? It's the same thing. This has to be multiplied by all 4 terms. If you want, you can, of course, you could rearrange it, right? Because it doesn't matter the order in which you multiply. So if you wanted to, you could stick the negative 3x to the 4th out front and then put the other polynomial behind it. And it's the same thing, right? You have to distribute in that negative 3x to the 4th regardless. Okay, so negative 3x to the 4th times x cubed. Well, again, there's an applied 1 in front of the x cubed, right? The coefficient of x cubed is 1. So negative 3 times 1 is negative 3. X to the 4th times x cubed, I have to add the exponent, so it'd be x to the 7th. Negative 3x to the 4th times positive 6x squared. So negative 3 times positive 6 is negative 18. And then x to the 4th times x squared is x to the 6th. Negative 3x to the 4 times negative 9x. Well, negative 3 times negative 9 is positive 27. X to the 4 times x is x to the 5th. And then negative 3x to the 4 times 10. Well, negative 3 times 10 is negative 30. And then I still have an x to the 4th. Right, so I have to write down the x to the 4th. So that would be the product of that monomial with that polynomial. It would be negative 3x to the 7th minus 18x to the 6th plus 27x to the 5th minus 30x to the 4th. Okay, what if you want to multiply two polynomials together and they each have two terms, right? They're called binomials. So what if I want to multiply two binomials together? So for example, let's say I have 5x minus 3. So that's one binomial, right? It's a polynomial with two terms. And I want to multiply it by another binomial, say 2x plus 1. Okay, so really what's going on here is we're going to use the distributive property twice, right? So I'll explain it. This is more theoretical, and then I'll show you an easier way that you can do this. So really we're using the distributive property twice. So think of 5x minus 3. Give that a new name. Call it maybe a. So a is equal to 5x minus 3. Okay. So right now I have a times 2x plus 1, right? Because I'm calling a that entire expression 5x minus 3. So what I can do is I can distribute in the a. So I have, I'll write this as 2x times a plus 1 times a. Right? I distribute in a. But remember what a is. A is 5x minus 3. So this is saying this is really 2x times 5x minus 3 plus 1 times 5x minus 3. So now I can use the distributive property again, right? I can distribute in the 2x. So 2x times 5x, well, I multiply the coefficients, that's going to be 10. And then x times x is x squared. 2x times negative 3 is negative 6, and I still have an x there. 1 times 5x is just 5x. And then 1 times negative 3 is negative 3. So I distributed in the 1, which really doesn't do anything, right? And then, of course, I can simplify this a little bit, right? I can combine like terms. So what is negative 6x plus 5x? That's just negative x. So my final answer is going to be 10x squared minus x minus 3. Okay? And we got that. Formally, it comes from using the distributive property twice. Okay? Now, that's not the way people normally do this. And there's a couple of different ways. Sometimes people will refer to this acronym called FOIL. So let me describe that real quick. So what FOIL is, I'll say we could also use the FOIL method. But this only works if you're multiplying a binomial times a binomial. Okay, if it's something more complicated, like a trinomial, if it has 3 terms or more, then it doesn't work. So we could also use the FOIL method when multiplying a binomial times a binomial. Okay, so what is the FOIL method? Well, it's just an acronym, and it stands for first, so that's where the F comes from, outer, or some people will say outside, I'll just use outer, inner, or again, you could use inside, so inner, and then last. Okay, so how does it help us with if we're multiplying a binomial times a binomial? Well, let me give you an example. Let's say I have 8x plus 5 times x plus 4. Okay, I want to multiply those two binomials together. So what the FOIL method says is first I multiply the first terms in each of the binomials, right? So first means the first terms in each of the binomials. So in this case, that would be 8x times x, right? Well, what is 8x times x? 8x times 1 is 8, and then x times x is x squared. Okay, so that's the first, right? That's the f. Outer means I multiply the outside term in the first polynomial, which is the 8, and the outside term, the furthest away from everything, in the second polynomial, which is the 4. So these two would be the outer. But what's 8x times 4? That's going to be 32x. Inner means I multiply the inside term, the term closest to the center in the first polynomial, which is the 5, times the term in the second polynomial that's closest to the center, which is the x. So this is what I mean by inner. So, and then what's 5 times x? It's just 5x. And then last means I multiply the last term in the first polynomial times the last term in the second polynomial. So 5 times 4 is 20. And then the only other thing you have to do is you have to combine like terms. So in this case, I have 32x plus 5x, right? I can combine those. So my answer is going to be 8x squared. And then 32x plus 5x is plus 37x. And then plus 20. Okay. Another way to think about this is anytime you multiply a polynomial together, every term in the first polynomial gets multiplied by every term in the second polynomial. That's really all you have to remember. Every term in the first polynomial. Actually, here, let me write that in general. So in general, when multiplying two polynomials together, and they could be anything. They don't have to be binomials. It can be any two polynomials. Each term in the first polynomial gets multiplied by every term in the second polynomial. So it gets multiplied by every term in the second polynomial. Okay, so if you know that, you don't even have to remember, FOIL method or anything. For example, if I have, say, I don't know, 2x minus 7 times 3x plus 4, okay? So what this rule says in general, you could use FOIL if you wanted to, that would be fine. You could use the distributed method twice, that also would be fine. It's sort of like the definition of this. But the easiest way is just use this general rule saying, okay, the 2x, right, that's one of the terms in the first polynomial, it's got to multiply by every term in the second polynomial. And then negative 7 also has to multiply by every term in the second polynomial. So 2x times 3x is 6x squared. 2x times 4 is plus 8x. Negative 7 times 3x is negative 21x. And then finally, negative 7 times positive 4 is negative 28. And then I can combine like terms. So the linear terms, the x terms, right, will combine. So what is 8x minus 21x? Well, that's going to be a negative 13x, right, minus 28. And then that would be the answer. So again, all I did in general is I took each term in one polynomial and multiplied by every term in the other polynomial. What would this be? Let's say I have u plus v times u minus v. So we'll use our general idea, or in this case, you could use FOIL, right? Because it's still a binomial times a binomial. So if I do u times u, that's u squared, right? 1u squared, I don't have to write the 1. U times minus v is minus uv. V times u is plus vu, but I could also write it as plus uv, right? Because the order doesn't matter. And I want to write it like that so it can help me cancel things later. And then finally, v times negative v is negative v squared. And then what's going to happen to the negative uv and the plus uv? You can think of this as negative 1 uv plus 1 uv. They're gone, right? Adds to 0. So this result is just going to be u squared minus v squared. So u plus v times u minus v is u squared minus v squared. Okay. So sometimes you can't simplify the final answer. You just can't do anything else with it. So, for example, if I had this, say x plus 7 times 6y minus 1. So if I multiply x times 6y, I'm going to get 6xy. Usually I do it in alphabetical order like that. X times negative 1 is negative x. 7 times 6y is plus, what's that, 42y. And then 7 times negative 1 is negative 7. But in this case, I can't combine like terms, right? There's nothing else I can do. So I would just leave it like that. That would be my answer, right? All 4 terms will stay. There's nothing that we can combine. Okay, let's do some examples now where we actually multiply more general polynomials. So let's say I have a plus 2 times a squared minus 4a plus 4. Okay, so again, the a, right, the first term in the first polynomial needs to be multiplied by every term in the second polynomial. And then the second term in the first polynomial now needs to multiply by every term in the second polynomial. So I'm going to get 6 terms, and then I can probably simplify some, okay? So let's do this out. So a times a squared is a cubed, right? I add the exponents. 1 plus 2 is 3. A times negative 4a is negative 4, and then a times a is going to be a squared. And then finally, a times positive 4 is just 4a. Then 2 times a squared is plus 2a squared. 2 times negative 4a is negative 8a, and then 2 times 4 is positive 8. Okay, now we can combine like terms, right? So a cubed, there's no other cube terms, so that's it. Square terms, I have a couple, right? Negative 4a squared plus 2a squared. What's negative 4 plus 2? That's negative 2a squared. Now I keep the a squared, right? Because I'm just combining like terms. A squared are like terms. So add the coefficients and keep the power. And then 4a minus 8a is negative 4a. Right? 4 minus 8 is negative 4. And then I just have a constant plus 8. So write that down. So that would be the answer. Right? I just multiplied each term in the first polynomial by every term in the second polynomial, and then at the end I combine like terms. Okay, here's another one. X squared plus xy plus y squared, all multiplied by y minus x. Okay, so the x squared has to multiply by both of these in the second polynomial. The xy has to multiply by both of these. And then finally the y squared has to multiply by both of these, right? So again, I'm going to get 6 terms, and then hopefully I can simplify some. All right, so what's x squared times y? Well, I can't really do anything else, so I just put them together, right? X squared y would be the product of those two. Just write them together. x squared times negative x. Well, 1 times negative 1 is negative 1, and then x squared times x is x cubed. Then I have xy times y. Well, that's going to be x, and then y times y is y squared, right? Xy times negative x is negative, x times x is x squared, and I still have a y here. Then I have y squared times y, that's y cubed. And then finally, y squared times negative x, I'll write it as negative xy squared. You could write it as negative y squared x, but it's easier to see like terms if you write it alphabetical order the same way. So I did x first and then the y, so negative xy squared. Okay, now can we combine any terms here? Yeah, it looks like I have a plus 1 x squared y and a minus x squared y. So that's gone, right? Just adds to 0. Then I have an xy squared and a minus xy squared. Good, that's gone. So I'm left with just negative x cubed plus y cubed. Or if you want, you could write this the other way, right? You could write this as y cubed minus x cubed. Either way would be fine. So that would be my answer in this case. Okay, what about this? 2s cubed t times 5s minus t squared minus 7s squared t squared times 9s squared minus 10t. Okay, so what I need to do is I need to distribute in the 2s cubed t and the negative 7s squared t squared, right? I need to multiply this in by both terms. So what is 2s cubed t times 5s? Well, 2 times 5 is 10. S cubed times s is s to the 4th, and I still have a t there, right? So I have to write down that t. Now, 2s cubed t times negative t squared. Well, 2 times negative 1 is negative 2. S cubed, but does not multiply by anything else, times 1, so it's just s cubed. And then t times t squared is t cubed. Then if I distribute negative 7s squared t squared times 9s squared, well, negative 7 times 9 is negative 63. S squared times s squared is s to the 4th, and I still have a t squared times 1, so t squared. Then finally, negative 7s squared t squared times negative 10t. Well, negative 7 times negative 10 is plus 70 s squared, and then t squared times t is t to the 3rd. Now, in this case, can I combine like terms? I guess not, right? Because remember, in order for them to be like terms, the variables have to be the same and the exponents have to be the same. So in this case, there's nothing that's exactly the same. So these are 4 individual terms. That's the best I can do. So I would just leave the answer like that. You could rearrange the terms if you wanted to, but I'll just leave it like that for this one. Okay, let me do one more example, and then we'll go on to 5.6. So let's say I want to simplify this expression. 8t squared plus 5t times 3t squared minus 2t plus 1. Okay, so in this case, the first thing I'd have to do is distribute in that 5t, right? Multiply in that 5t. So 5t would get multiplied by all 3 of these terms. So I can't do anything with 8t squared. I'll leave that out front. 5t times 3t squared is going to be 15t cubed. 5t times negative 2t is, well, 5 times negative 2 is negative 10. And then t times t is t squared. And then 5t times positive 1 is just 5t. Okay? And now, since we're adding everything together, we could combine like terms, right, if possible. And it looks like, let's see, there's only one cube term, so I'll just write that down. So 15t cubed. But it looks like the square terms I can combine, right? I have 8t squared minus 10t squared. Well, 8 minus 10 is negative 2t squared. And I still have a plus 5t. So that would be the answer in that case. All right, great. So it's not too bad, right? So we're just, when we multiply, each term in one polynomial gets multiplied by every term in the other polynomial. And all you're doing is you multiply the coefficients and using the product rule to multiply the variables, right, the powers. Okay, the next section, 5, 6, this is a section that, in theory, we don't really even need to do this section because we have all the techniques that we need to multiply polynomials together. This is just given sometimes to save a little bit of time if you recognize the particular form of the polynomial. So I want to talk about this, but I will also show you other ways that you can do these things. In fact, we already know all the different techniques that we need. But let me mention these because you will sometimes hear these terms. Okay, so this is 5.6, and it's on special products. Okay, so the first one, the first special product, is something called the square of a sum. So what does that mean? Let me write this better here. If I have a sum, and I'll just use a plus b for my general terms, and I square it, what does that equal? Well, it turns out that it equals a squared plus 2ab plus b squared. So if you're given a particular question that has the form, right, has this form, something plus something squared, you could just plug into this equation and that would be your answer. But where does that equation come from? Well, it comes from just multiplying out those two polynomials, right? Remember what a plus b squared means. So a plus b squared, this means a plus b times itself, right? Times a plus b. So we can multiply this out, right? In fact, you could use FOIL in this case because they're both binomials. But in general, we know that each term in the first polynomial has to multiply by every term in the second polynomial. So a times a is a squared. A times b is plus ab. B times a is ba, but we can also write it as ab. And then b times b is b squared. But what's ab plus ab? Remember, this is like 1ab plus 1ab. They're like terms, right? So I have two of them. So it's 2ab plus b squared. And that's where it comes from, right? This is exactly what I had up here for my formula. By the way, be careful because a common mistake, I'll say be careful. Avoid this common mistake. A lot of times people will say, if I have x plus y squared, that's just equal to x squared plus y squared, right? But this is not true. This is not equal. It's wrong. What is x plus y squared equal to? Well, you could use the formula that we just learned, or you could actually multiply this out. Remember, this means x plus y times x plus y. So if you distribute, or if you multiply each term in the first polynomial by every term in the second polynomial, or if you use FOIL, in this case, you're going to get x squared. But then x times y is plus xy. Y times x is also, I can also write as xy. and then y times y is y squared. So I have x squared. I can combine like terms. Remember, this is like 1xy plus another xy, so this is plus 2xy plus y squared. So a lot of people forget this middle term, right? It's not equal to x squared plus y squared. It's equal to x squared plus 2xy plus y squared. So you got to be just careful with that. It's a common mistake that students make. Okay, so why would we use this formula? And again, you don't have to do it this way. You don't have to use this formula at the top here. You could just FOIL everything out and not even bother with this section. But sometimes people like to memorize these formulas and use these. Sometimes they're a little quicker. So let me give you an example where you could use this. Let's say this is the problem you want to solve. You want to do 5x plus 3, and you want to square it. Okay. So what you could do is you could say, oh, the 5x is like my a, and the 3 is like my b, right? And remember, I know that a plus b squared is going to be a squared plus 2ab plus b squared. So what I could do is I could plug in now, right? Where I have an a, I would plug in 5x. So this, here, I'll write it here. So remember, this could be a squared plus 2ab plus b squared. So I have 5x, that's my a, squared, plus 2a is 5x, b is 3, and then plus 3 squared. Well, what's 5x squared? 5x squared is, I'll do it on the side here, you can either use your rules, right? You could write this as, remember, if I have a product raised to a power, it's the first thing raised to that power times the second thing raised to the power. And that is going to be 25, because 5 squared is 25x squared. Or you could also think of it as, this means, 5x squared means 5x times 5x. And that will also give you 25x squared. Right? Either way, they really mean the same thing. So this is going to be 25x squared. And then 2 times 5x times 8. Well, 2 times 3 is 6, times 5 is 30, right? And then I still have an x there. And then what's 3 squared? That's 9. So that would be the answer. It'd be 25x squared plus 30x plus 9. So in this case, we use that special product, right? When we had the square of a sum. What if you didn't want to do it this way? Okay, fine. So let me do this problem again. 5x plus 3. You could just say, well, I know how to do this in general. So same problem, this is just a different way of doing it. If you didn't want to use that special product, you could say, well, I know that this is equal to 5x plus 3 times itself. So how do I multiply these two binomials? I could use FOIL, or I could just say the first term in the first polynomial gets multiplied by both terms in the second, and the second term gets multiplied by both terms. So 5x times 5x is 25x squared. 5x times 3 is plus 15x. 3 times 5x is plus 15x. 3 times 3 is plus 9. And then I can combine these two terms, right? So I have 25x squared plus 15x plus 15x is 30x plus 9. So you don't need to use a rule. It's optional. Some people like it, some people don't like it, right? So it's totally up to you, because you could always go back to the basics and just multiply it out. Okay, what's the second special product? Well, it's similar to this, but instead of the square of a sum, it's the square of a difference. And what it says is if I have a minus b squared, that's going to equal to a squared minus 2ab plus b squared. How do we know that? Well, we could prove it just by multiplying it out, right? I could show you by multiplying out. So if I have a minus b times a minus b, I want to FOIL this out or multiply it out. So what's a times a? That's a squared. A times negative b is negative ab. Negative b times a is negative ba, but I can also write it as negative ab. And then negative b times negative b is positive b squared. And then look what happens. I can combine like terms, right? Negative ab minus another ab is minus 2ab plus b squared. So that's where it comes from. It's just, you just actually carry it out, multiply it out, and you'll get that right-hand side. So if you're given some problem, you might want to use this formula. If you have it memorized, right? It can be quick if you have it memorized. So let's say we're given the problem 2x minus 1 squared, right? And we want to use that formula. Well, so in this case, the a is like my 2x. And you got to be careful. It's a minus b, right? So the b is like my 1 in this case. Right? So if I were to plug into that formula, I have a squared minus 2ab plus b squared. So a is like 2x. So this is 2x squared minus 2 times 2x times 1 plus 1 squared. So 2x squared is going to be 4x squared, right? 2 times 2, x times x. Negative 2 times 1 is negative 4, and I still have an x there. And then what's 1 squared? Well, that's just 1 times 1, so that's equal to 1. And that would be it. So 4x squared minus 4x plus 1. Well, what if I didn't want to use this formula? Okay, you don't have to, right? We could just do it directly. You could say, I know that this means, so I know that 2x minus 1 squared, this means 2x minus 1 times itself. So let me just multiply this out, right? I'll FOIL it out or use my general rule for polynomials. So 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is another negative 2x. Negative 1 times negative 1 is plus 1. And then again, look what happens. I can combine those middle terms, right? The x terms. Negative 2x minus 2x is negative 4x plus 1. So of course you're going to get exactly the same thing. And it's up to you if you want to use the special product or if you want to just do it out like you normally would, right? Just multiply it out like you normally would. I think in many cases it's easier just to multiply it out, right? Unless you have it memorized, then it could be a little bit quicker. Let's do another one. So let's say I have 5a squared minus c squared squared. So again, if I wanted to use that formula, think of this as, I'll call this like capital A, and then my c squared is like my capital B. So I know that my answer has got to be a squared minus 2ab plus b squared. So this is going to be 5a squared all squared, right? Minus 2 times 5a squared, and then times b, which is c squared, and then plus b, c squared all squared. Okay, so use your rules for exponents now, right? Remember, 5a squared squared means it's a product, right? It's being squared, so the first term gets squared, and the second term gets squared. Now we can use the power rule, right? Because in many cases here, if I have a squared raised to another power, raised to the second power, remember the rule is you multiply the exponents. So in this case, first of all, I can do 5 squared, that's 25. And then a squared squared means a to the 4th. Now I have negative 2 times 5, that's a negative 10. And I can't really do anything else, right? I'll leave the a squared, c squared. I can't combine those. And then plus, here I'd use the power rule again. C squared squared means c to 2 times 2, which is the 4th power. So that would be my result. Right, so 25 a to the 4th minus 10 a squared c squared plus c to the 4th. And if you don't like doing it that way with the formula, then just write it like this. So it's 5a squared minus c squared, right? Squared. Remember, this just means 5a squared minus c squared times itself. So then you could just FOIL it out, and you're going to get exactly the same answer. Okay, so it's totally up to you, like which technique you want to use. Okay, now there's one more special product that and this one actually can be a little more useful because this one comes up a lot. It's the product. Out of all of them, this is the one I would maybe memorize because this one could be useful. The product of the sum and difference of two terms. Okay, so what do I mean by that? I mean, if I have a sum of two terms, say a plus b, and then multiply by a difference, say a minus b, it turns out that the result is going to be a squared minus b squared. There's no middle term. It cancels, okay? How do we prove that? Well, we could prove it right here just by multiplying this out. So if I do a plus b times a minus b, well, a times a is a squared. A times b, or a times negative b is negative ab. B times a is plus ba, but I can also write it as ab. And then b times negative b is minus b squared. And look what happens to the like terms. I have negative 1ab plus 1ab. They're gone, right? That's just 0. So I'm just left with a squared minus b squared. Okay. So again, this one kind of can be useful because if you recognize it, then it's just a quick way to multiply. So for example, let's say I give you, r plus 8 times r minus 8. Well, yeah, that's a sum times a difference, right? In fact, if you want, you could say a is kind of like the r and b is like the 8 because it's a plus b, a minus b. So what is the answer going to be? Well, it's going to be a squared minus b squared. But what it is 8 squared? That's 64. So it's r squared minus 64. And then you're done. So it's just quick if you remember this one rule. Let's say I have m. It doesn't matter what order, right? If I write this as let me do it over here, just so I don't. Instead of a plus b times a minus b, I could also write a minus b times a plus b. Right? It's the same exact thing. It's still going to equal a squared minus b squared. The order of these two terms, or two factors in front, doesn't matter. Okay? So in this case, it's still the product of a sum and a difference. Just happens the difference appears first and then the sum after. So let's say I have m minus a quarter times m plus a quarter. Okay, so you recognize, oh, this is a special form, right? It's a minus b times a plus b. Well, what is the answer going to be? It's going to be a squared, so m squared. A is like my m in this case, and b is like my 1/4, minus 1/4 squared. But what's 1/4 squared? That's 1/4 times 1/4, which is 1/16, right? 1 times 1 over 4 times 4. So it's just m squared minus 1/16. That would be my answer. All right, let's do a few more of these. Let's say I have 10t plus 3s times 10t minus 3s. Okay, again, if you wanted to, if you didn't recognize that this has this special form, right? This is a plus b times a minus b, right? Where the a is 10t and the b is 3s. So you could plug it into that formula and solve it quickly. If you didn't see that, you could always FOIL it out like you normally would, multiply it out like you would in general. So 10t times 10t is 100t squared. 10t times negative 3s is negative 30. I'll write it as st, just alphabetical order. 3s times 10t is plus 30 st. And then 3s times negative 3s is negative 9s squared. And what's going to happen to the st terms in the middle, the like terms? They're going to cancel, right? So you're left with 100t squared minus 9s squared. So even if you forget the formula, you can always just multiply it out and you will get the correct answer at the end. So again, it's totally up to you on whether you want to use these special products from this particular section. All right. Here, let me do one more, and then I'm going to do one word problem, one applied problem, and then we'll do the last section, which is 5-7 on division of polynomials. So I'll do one more of these. Let's say I have 2h minus 7k, and then 2h plus 7k. Okay. Even if I didn't remember the formula, right, I could multiply that out and I'd be fine, right? I would get the correct answer. But let's say I recognize, oh yeah, this is like a minus b, where a is 2h, b is 7k, and then a times a plus b. So I know my result has got to be a squared minus b squared. So in this case, a is 2h, so it's 2h squared minus, and then b is 7k squared. Well, what's 2h squared? That's going to be 4h squared, right? Minus, and then 7k squared is 49k squared. Right? Remember, 7k squared is 7 squared times k squared. Or it's 7k times 7k. You could do either way. And 2h squared is 2 squared times h squared. So that would be my answer. In this case, I just decided to use that rule. If you just want to FOIL it out in general, you'll get exactly the same answer. Okay. Here, let's do one applied problem which sort of involves all these things. Let's say you're told a carpenter measures the side of a wooden square to be x with the margin of error e. And we don't know exactly what those values are, but you know, there's going to be some error with measurement, right? Let's say you measure that that wooden square and you find it to be, I I don't know, 2.5 inches, but there could be an error, say, within, you know, a tenth of an inch, like 0.1 inch. So in this case, X would be 2.5 inches and E would be 0.1 inches, right? It's the possible error that you could have made because you can't read any instrument exactly. And then the question, okay, so you're given that information. Now the question is, what is the difference in area between the wooden square with the largest possible dimensions and the wooden square with the shortest or least possible dimensions? Or smallest, I guess is even better. And the wooden square with the, I'll call it smallest possible dimensions. Okay, well, let's draw a picture, right? So let's figure out what's going on here. So let's say I'll draw the largest possible wooden square first. So what this means is, right, I measure the side to be length X, but I could have made an error as much as E. So the largest that the length could have been, if I made the total amount of error, is X plus E, right? Think back to the example I gave. Let's say X is 2.5 inches, and then E is a tenth of an inch, or 0.1 inches. Then the side would be 2.5 plus 0.1, right? It'd be 2.6. So I have to add the error. And then this side would also be X plus E. So this is like the largest that the area could be, right? If I made an error where I added the E, the error, in both measuring the length and the width. And then the smallest possible square would be if I made an error in the other direction, right? Instead of getting X, I get X minus that little bit of error. And same thing for the width here. So this is like the smallest possible area. Okay, so how do I find the area of a square? Or you can think of it as a rectangle if you want, right? So the area, I'll call it, well, in general, we know the area of a rectangle is length times width. And for a square, you can say it's the side length squared, right? Because the length and width happen to be exactly the same value. So you could use either formula, right? You'll get the same answer. I'm going to call this AL for largest, the area of the largest. In this case, it's going to be X plus E squared, right? But that's the same as X plus E times X plus E. So we can work this out, right? You could either use your special product rule, because that's the square of a sum, or you could just FOIL this out. It might be easier just to FOIL this out. So what is this going to be? It'll be X squared. Then I'm going to have a plus XE. Then another plus EX, but that's the same as XE. And then plus E squared. So this is going to be X squared. If I combine these two terms together, I'm going to get plus 2xe plus E squared. That's the area of the largest wooden square when I expand it out. Now, what about the smallest? Well, for the smallest, right, I'll call it AS for smallest, it's going to be x minus e squared, which I can write as x minus e times x minus e. So if I multiply this out, and you can double check me here, I'm going to get x squared minus 2xe plus e squared. All right, now what did this question ask? It said, what is the difference in area between the wooden square with the largest possible dimensions and the wooden square with the smallest possible dimensions? Well, the difference is going to be the area with the largest possible dimensions minus the area with the smallest. So it's a sub L minus a sub S, right? And remember what these were. This was, a sub L was x squared plus 2xe plus e squared. And I want to subtract x squared minus 2xe plus e squared, right? This was AL, the first term, and the second one is AS. Well, last time we learned how to subtract polynomials, right? Remember, all you have to do is, well, the first one is fine. I can remove the parentheses, right? There's nothing going on there. So this is x squared plus 2xe. I'm going to try and squeeze this in on the bottom here. But remember, the second one, I'd have to distribute in this -1, right? Or change all the signs in that second polynomial. So that becomes a negative x squared, a plus 2xe, and a negative e squared. Now look what happens when we combine like terms. X squared is going to cancel with negative x squared. That's gone. E squared is going to cancel with negative e squared. And then what's 2xe plus 2xe? It's 4xe. And that's my answer. So the answer to that question is 4xe. It seems very abstract, right? But all we're doing is we're using our rules for multiplying polynomials, and then at the end we had to subtract polynomials. So it's just good practice in multiplying and adding and subtracting polynomials. Okay? Don't worry too much about that if that didn't make complete sense. It's just an application. All right, last but not least. Right, last section, 5.7. So this is on division of polynomials. And we're only going to talk about two different things here. Right, we're not going to get super complicated with this. We're going to divide monomials, so a monomial divided by a monomial. And then once we understand that, then we're going to go a little more complex, and we're going to divide a polynomial by a monomial. But we're not going to do a polynomial by a polynomial in general. We're just going to, we'll end with a polynomial divided by a monomial. So let's first talk, because this is going to kind of build on one another. Let's talk about dividing monomials first. Remember, a monomial is nothing more than a polynomial with just a single term. Okay, so how do I divide monomials? Well, you really, the rule is you just divide the coefficients first. So I'll say just divide the coefficients then use the quotient rule of exponents to divide the variables. Okay, so let's do some examples and it'll make more sense. Let's say I have 6x cubed. I want to divide by 2x squared. Okay, so first thing, divide the coefficients. Well, what's 6 divided by 2? Well, that's easy. It goes in evenly, right? 2 goes into 6 evenly. It's 3. And then x cubed divided by x squared. Remember, if you're dividing powers and they have the same base, you keep the base. And then what's the rule for the exponents? If you're dividing, you subtract the exponents. So 3 minus 2 is 1, but then you never write the 1. You would just leave this as 3x, right? And that would be the answer. Let's say I have negative 4 x to the 5th, y to the 4th, divided by negative 2 x squared y. Okay, so same idea, right? I divide the coefficients. Well, negative 4 divided by negative 2 is a positive 2. X to the 5th divided by x squared is x. And then what's 5 minus 2? 3, right? I subtract the exponents. And then y to the 4th divided by y. Remember, there's really a 1 here, right? So this is going to be 1. And then 4 minus 1 is also 3. So that'd be my answer. 2x cubed, y cubed. So not bad, right? And another one, I mean, sometimes you can only simplify the fraction. You can't really, you won't get an integer answer. So let's say you have this. So in this case, negative 10 over 8. Well, 8 doesn't go into 10 evenly. So the best I can do is I could simplify that, right? 2 goes into both of them. I could write this as negative 5/4. Then x cubed over x squared is x to the 1. So I just leave it as x. Y to the 1 over y to the 1 is y to the 1 minus 1, which is 0, right? Which is, remember, anything to the 0 power is 1. Or the other way to think about this is the y's cancel, right? So there's no y there. And then z squared over z is also going to be z to the 1, which I just write as z. So that would be my answer. It'd be negative 5/4 x z. Okay, what about now dividing a polynomial by a monomial? So dividing a polynomial by a monomial. Meaning a polynomial in general, right? Typically more than one term. Because really what we just did is also dividing a polynomial by a monomial. It just so happens that the polynomial is also a monomial. But in general, let's say I have, here it's best to explain this by example. Let's say I have 12m to the 4th plus 15m cubed, and I want to divide that by 3m. Okay. The first thing that you should do is you should rewrite this. Remember, what this means, right? This is the same as putting the 12m to the 4th over 3m plus, and then 15m cubed over the 3m. Right? If you were to add those fractions together, you would keep that denominator and add the numerators. We're just going the other way, right? We're splitting it up. So it's 12m to the 4th over 3m plus 15m cubed over 3m. And now look at this. I have exactly what I just did up above, right? I have a monomial divided by a monomial. So how do we handle that? Well, I do the coefficients first. 12 divided by 3 is 4. M to the 4th divided by m. Remember, m means m to the 1. So it's 4 minus 1. So it would be m cubed. And then plus 15 divided by 3 is just 5. And then m cubed over m is m squared, right? 3 minus 1 is 2. And that would be my answer. Okay, let's do a bunch of these just for practice. Let's say I have 8x to the 5th plus 4x to the 4th minus 16x cubed divided by 4x squared. So again, first rewrite this. This is going to be the first term over 4x squared plus the second term over 4x squared plus, I'll even write plus here, the third term, and I'll write it as negative 16. So I'll keep the negative with the 16x cubed over 4x squared. And now I'm just dividing monomials, right? So what is 8 divided by 4? That's 2. X to the fifth divided by x squared is x cubed, right? 5 minus 2 is 3. Then I have 4 divided by 4 is just 1, so I don't even have to write the 1. And then x to the fourth divided by x squared is x squared. And then finally, negative 16 divided by positive 4 is negative 4. And then x cubed over x squared is x to the 1, which I just leave as x. And that's it. Nine y to the sixth minus 3y to the fifth minus 2y to the fourth all over negative 3y to the fourth. Okay, so again, rewrite this, right? This is the same as 9y to the sixth over a negative 3y to the fourth. And I'll always add the terms plus, and then this is going to be negative 3y to the fifth over negative 3y to the fourth plus negative 2y to the fourth over negative 3y to the fourth. Okay, so now I have to just divide these monomial by monomial. Well, 9 divided by negative 3 is negative 3. Y to the sixth divided by y to the fourth is y squared, right? 6 minus 4 is 2. Negative 3 divided by negative 3 is 1. And then, so I don't even need to write the 1. And then y to the fifth divided by y to the fourth is just y, right? 5 minus 4 is 1. The other way to think about it is you have 5 y's in the numerator, 4 y's in the denominator, right? Y times y times y times y times y in the numerator, and then 4 of them in the denominator. And 4 of them are going to cancel, and you're going to be left with 1 of them in the numerator. But the quick way is to subtract the exponents. And then finally here, y to the fourth over y to the fourth is y to the 0, but that's equal to 1. But we already know that because we know that these are going to cancel, right? We're just going to get a 1 there. So I would just leave this as, well, negative 2 divided by negative 3 is positive, and then you can't do anything else, so just leave it 2/3. So that would be the answer. Negative 3y squared plus y plus 2/3. Okay, 10ab to the eighth minus 4ab to the sixth plus 6ab to the fourth, all divided by negative 2ab to the fourth. So again, we're going to rewrite this, 10ab to the eighth over negative 2ab to the fourth plus negative 4ab to the sixth over negative 2ab to the fourth plus 6ab to the fourth over negative 2ab to the fourth. Okay, so now if I divide each term, which is just a monomial divided by monomial, I have 10 divided by negative 2. Well, that's negative 5, right? A divided by a is just 1, right? So that's gone. And then b to the 8th divided by b to the 4th is b to the 4th. Plus negative 4 over negative 2 is positive 2. A divided by a again is 1, so that's gone. And then b to the 6th divided by b to the 4th is b squared. Plus, and then 6 divided by negative 2 is negative 3. So really I could write this as, minus 3. And then a divided by a is 1, so that's gone. And then b to the 4th over b to the 4th is also 1. So just minus 3 at the end. So it's negative 5b to the 4th plus 2b squared minus 3. All right, a couple more and then that'll be it. Okay, let's say I have 6x squared y cubed minus 18 x cubed y to the fourth plus 9 x to the fourth y to the fifth all over 6x squared y to the third. All right, so I'm going to rewrite this, right? I'm going to split it up. So it's 6x squared y to the third divided by 6x squared y to the third plus negative 18x cubed y to the fourth over 6x squared y cubed plus 9x to the fourth y to the fifth over 6x squared y cubed. Okay, well, actually this first term, right? 6 divided by 6 is 1. X squared divided by x squared is 1. Y cubed divided by y cubed is 1. Or the other way of thinking about it is if I have anything, 6x squared y cubed divided by itself, that's just equal to 1, right? So that's just 1. Then here I have negative 18 divided by positive 6. Well, that's going to be a negative 3. X cubed over x squared is x, right? 3 minus 2 is 1. And then y to the fourth over y cubed is y. 9 over 6, well, 6 doesn't go into 9 evenly, but I can simplify that. 3 goes into both, so I can write this as 3 halves. X to the fourth over x squared is x squared. And then y to the fifth over y cubed is y squared. So that would be my answer right there. Okay, and then the last one. Let's say I have 15 a to the 8th b minus 21 a to the 4th b minus 24 a cubed b, and I want to divide by 3 a cubed b. All right, so split it up. So I have 15 a to the 8th b over 3a cubed b plus a negative 21 a to the 4th b over 3a cubed b plus negative 24 a cubed b over 3a cubed b. All right, so now we can divide each. Right, remember, each term now is just a monomial divided by a monomial. So and we know how to handle that. 15 divided by 3, positive 5. A to the 8th divided by a cubed is a to the 8 minus 3. So that's going to be 5th. And then b divided by b is 1, right? They cancel. The b's cancel. Negative 21 divided by positive 3 is a negative 7. So I'll write this as minus 7. A to the 4th over a cubed is a. Right, a to the 1, which is a, and b over b cancels. And then finally, a negative 24 divided by positive 3 is a negative 8. And then a cubed over a cubed is 1. Right, that's gone. And b over b is also 1. So it's just negative 8. So 5a to the 5th minus 7a minus 8. Great, that's it. So that was the last lecture for Algebra 1. So what I'll do next is I will do a video lecture on the practice sheet for 5B, and then a video lecture on the practice final exam, the exam that covers the entire course. But again, these exams, given the situation with the COVID-19 virus, these exams will all just be given on My Open Math, and they'll be very similar to the quizzes and the homeworks that you've been doing. Great. Have a good night.